Can you tell us more about your particular area of research and kind of what drew you to that?
Right. So the research field that my group works on is the field of non-viral gene and nucleic acid delivery. And so actually I was first attracted to this field when I applied to Professor Mark Davis's lab as a postdoc. I honestly I wasn't aware of this field until I applied for the postdoc because I'm a materials chemist, so I have a PhD in chemistry. And, but my PhD work is more in solid state materials and in particular creating things that could be used for environmental remediation. When I applied for a postdoc, he had just started this research field in his lab, and when he told me about this project of creating polymers to deliver genes into cells that could be used to treat cancer, I was just absolutely taken back by this work. And I thought, oh my gosh, I have to work on this project. And so when he hired me, I learned all about this area, worked really hard, and I have been inspired in this field ever since my postdoctoral training.
So you mentioned your Professor Davis. Was he the primary? Would you say he's the primary mentor, I guess, along your path, or have there been other mentors that have kind of helped you progress?
Well, Professor Davis has been a primary mentor to me. So he is my postdoc advisor. Obviously, my PhD advisor, Omar Yaghi, has been a big mentor to me. In this field, I would say Mark Davis has been because of his work, and he has a similar background. He sort of switched fields, so he started in inorganic and solid state catalysis, so that's why I originally applied to his lab, but then got into this field because his wife had cancer. And so interestingly, I have a similar experience where my mother went through cancer treatment, and I experienced that, and it's life-changing when you have a loved one going through something very devastating in their life. And so kind of a combination of educational mentors in addition to some personal things, this field has been really very dear to my heart, and particularly being a part of the society has driven the future of my work and driven me to inspire a lot of other people, my students in my own postdoc. It's a great honor, and in fact, I was pretty surprised when I found out I won it because, I've been going to these meetings since I was a postdoc, and starting out essentially from ground zero and building up my career in the field, it's obviously a great honor. I've worked really hard. My students in my lab have worked very hard in the field, and it's really wonderful to be recognized for our work. But obviously there's a lot of great work going on in our field. So to be chosen for this it's been really a great honor.
Other contributions you hope to make within not only this particular area of research, but within the society as well, moving forward?
Yeah, so I've actually already sat on the non-viral vehicle committee, which is now the molecular conjugates committee. I also chaired that committee. And I hope, to be quite honest, to become a leader in the field and hopefully move our research more toward clinical trials. We've done a lot of fundamental work where we synthesize a lot of polymers and, hopefully just guiding some of my students in this field, remaining members of the society, and potentially still taking leadership roles in the field of non-viral gene delivery, hoping, in the future to still contribute talks and many posters with my students and postdocs, and, maybe move, obviously, more toward the clinical side, since that's what, kind of new to us and where we're really moving toward.
In what ways do you think the society as a whole has contributed to your research and your scientific career development?
Right. So interestingly, because my research really sits on the interface of organic chemistry, polymer chemistry, biomedical engineering, chemical engineering, and obviously gene therapy research, coming to these meetings is really a great experience for myself and my group because there's it's all focused on gene therapy and cell therapies, but there's a very wide breadth of different research in this field. So for example, if I go to other meetings, sometimes it's more focused just on polymer chemistry. Whereas here at the Society, we get a really broad depth and spectrum of what's going on in the field. So from non-viral, polymer synthesis, lipids, cellular delivery, for example, ex vivo, in vivo, clinical trials. And so the clinical trials and the viral aspects is something my group is not as familiar with, and something that, of course, coming to these meetings, we get to see really what's the forefront of the research in this field moving into clinical trials and in clinical trials. And that's something that we learn a great deal about coming to these meetings, whereas going to other meetings that are more focused on biomaterials are typically more on the fundamental side, where we get much more of an applied flavor to what, where we really want to move with
just being able to sit into
talks, that seeing people that are doing viral delivery and having things in the clinic is really inspiring to us and to me.
For those, for another student or another fellow who's wanting to get into the field of gene and cell therapy, can you offer some advice or some tips to kind of help them progress similar to in the way that you have?
Right, yeah. I guess my first thing is just really love what you do, because I do, and it drives me every day to come in and guide my students on these projects. We absolutely love this field. Every field has ups and downs, and obviously this is driven sometimes by the economy, so it's just to kind of really do what you love, be passionate about what you love, and don't get discouraged by, for example, kind of trends and fields, and I guess be creative. So that's something that I always try to foster in my group, is to really draw from a number of different fields. And so I have had a unique background in having done a PhD in a completely different field than my postdoc work, which is what I've decided to continue my PhD career, or sorry, my faculty career with. And it's allowed me to really pull a lot of creativity into our research to build materials that, for example, have imaging agents incorporated into them that could be used as theranostics, so therapeutic and diagnostic delivery vehicles for nucleic acids. Go to talks and meet people from the society, meet people from all areas, and foster a lot of creative collaborations from areas, because that's the creativity and getting sort of new ideas into the field is really what pushes any field kind of. I guess the formula is just to be social, meet people, don't hesitate to ask questions. There's really no dumb questions, especially coming from somebody who switched fields. If you don't know something, ask, and go up to investigators after their talks and talk to them further about their research. Really find out as much as you can from some of the senior investigators in the field. And that's what's kind of really nice about these meetings, is that they have these meet the investigator sessions and some mentoring sessions, and that's something really special about these meetings, and that I would suggest a lot of young investigators to really take advantage of, because the senior investigators are there to help. They have experience with the NIH and writing proposals, successful proposals, and also doing some successful research. So that's something definitely to take advantage of, is to meet as many people as you can, talk to as many people, and just really ask people a lot of questions. And everybody's always excited to talk about their research.